Okay, so, yeah, like I said, this one has to be factored. So 8x squared plus 2x minus 21 over 4x plus 7. I forgot that in class. So to factor, basically, you're looking at FOIL, right? So what times what is 8x squared? 4x and 2x. And then what makes 21? 3 times 7. Which order? I don't know. I'll just write it down. So if you're having trouble factoring, I know that's often a sticking point for people. Just try stuff. So just write it down, 3 and 7, because 3 and 7 make 21, and 4 and 2 make 8. Maybe it's right, maybe it's wrong, I don't know. Just stick in a couple plus signs for now, and then just FOIL it and see what happens. The more you FOIL, the better you'll get, and pretty soon you'll be able to tell whether it's right or not. 8x squared plus, what'd that be, 28x, right? You can all FOIL, I know that. 6x and 21. Is that right? These two middle ones would make 34x. Is that what I want in the middle? No, not even close. So what do you try to do to fix it right away? Switch to 3 and 7. I'll do the signs in a minute. Let's just switch to 3 and 7. Which way were there? 7 here now, 3 there? So try it again. What happens? Well, now the middle stuff kind of changes. What do we have now? We have 8x squared plus 12x plus 14x plus 21. And now, to make plus 2 in the middle, you've got to make this has got to be negative 12, doesn't it? And the 21 is also got to be negative, doesn't it? What's going to make those two guys negative? Negative on the 3, you see. Because negative 3 times 4x will be negative 12, and negative 3 times 7 will be negative 21. Now it's right. See how I just fiddle around with it till it works? There's really nothing more than that. Just keep fiddling until it's right. And now really I should have used a little insight and said, look at the bottom, 4x plus 7, I bet they're going to make a 4x plus 7 on the top. That would have helped me out a little bit. But anyway, so there we go. See, they cancel. So in the end, it's just 2x minus 3. So when it comes to the vertical asymptote question, there's no denominator anymore. It cancels out. So vertical asymptote, none. Because remember, you're supposed to set denominator to 0. There is no denominator. It canceled out. So there's no vertical on this one. That's why. Make sense? We good? I better go to the... Okay. Here we go. So y equals x plus 7 over x plus 9. So they're going to go through the battery of questions that you basically did in last night's homework. A lot of it's the same thing. They're going to say, what's the domain? How do you find domain? You say denominators cannot be 0, right? So you just say, all right, grab that denominator, x plus 9 cannot be 0, which means what? X cannot be 0 or negative 9. So that's what I chose right there. Good so far. Domain is just denominators can't be 0 because that chokes the fraction. Can't have 0 in the bottom of a fraction. Now, vertical, if you're thinking, well, isn't vertical asymptote the same? Virtually the same, you're right. Vertical asymptote, you just say denominator, you got to be 0, right? That's why so it's going to be the same answers, isn't it? Just going to take that denominator, same denominator. This time we're setting it equal to 0 instead of not equal to 0, but it's basically the same thing. 0 and negative 9, sure enough. Because those are the places where there's vertical asymptotes, those are the places where the domain doesn't exist, right? Because you can never touch a vertical asymptote. So they're the same thing. Now, there's one small exception, which we will see in probably within 5 minutes. So let me just say it now. I'll write it and show it in a minute, but let me just put the idea in your minds right now. There is one somewhat important difference between domain and vertical. They look so similar. Domain is done before canceling, and vertical asymptotes you do after canceling. Now, we didn't have any canceling in this. I mean, like the one we just did where I factored and I canceled. We don't have that on this one. There's nothing canceling there. They're not the same. But in a minute, we'll see one where they cancel, and I'll let you know you have to answer the domain question before canceling and the vertical asymptote after canceling. That's the difference. Why? Because domain, if it was ever there, it's a problem. Doesn't matter that you canceled it out. If it was ever there, domain's going to choke. So you need to answer the domain question before you cancel anything. Whereas vertical, it's just normal. If it cancels out, it's gone. Just don't pay attention to it anymore. But the domain's weird. The domain must be done before canceling anything. Because if anything was ever there, even though it later canceled, whatever, it was there for a minute, it's a domain problem. So that's a difference. All right, so let's go on. So there's vertical, and so we'll get to that. We don't have that in this one. We'll get to it in a minute. It's probably one of the trickiest things. All right, next question. What's the horizontal or oblique? Still remember how to do horizontal and oblique? You okay with that? Let me go to a fresh screen here. So horizontal and oblique. Horizontal and oblique. How do you do horizontal? What's that whole thing about numerator power, denominator power, right? We have x plus 7 over x plus 9. So that's x plus 7 over x squared plus 2. You have to multiply it out because that way you see the actual power. The numerator power is 1, right? 1 power here. Denominator power is 2. You got to see the actual powers in the numerator and the denominator, right? That's how we decide on that, on the horizontal, yeah.
So define
Cyrus.
Define the power if it's in if it's a parentheses and you could distribute it, so you do that to find the power.
That's right. Because this is really an x squared kind of thing. Yeah, so you have to actually, that's right. To see the actual power, you're going to have to FOIL it. Yeah, that's right. Yeah, remember we did that before when we talked about in behavior. Yeah, maybe tie it in for you that way to make you see it's really not something new. Remember when we did in behavior and then we would look at something and I would say, look, just take the highest power times the highest power, or whatever that comes out to be. That's the real power of that thing. Same kind of thing here. We're saying, what's the real power of the denominator? Second power. What's the real power of the numerator? First power. So remember when the denominator wins the tug of war, what does that mean, right? Denominator is bigger power. The denominator is more powerful. So as you go way off to the right, it is about in behavior. Horizontal asymptotes are what happens in the end, right? We're saying way off to the right is the graph going to do a certain thing. So if you plug in like 10,000, way off to the right, what's going to happen? Well, the bottom is more powerful than the top. So 10,000 squared is way bigger than 10,000 plus 7. Right? The bottom's going to win. So if the bottom wins, that's like, it ends up being like 1 over 10,000, which is basically 0. Right? If you eat 1/10,000th of the pie, you basically ate no pie. Right? You just smelled the pie. So it's 0. It's basically 0. So that's the horizontal asymptote, y equals 0. That means this function, as it goes to the right forever, eventually will flatten out because the denominator is more powerful and pulls it down to ground. It grounds the plane. It pulls it down because it's more powerful. Make sense? That's the horizontal. Remember all that from yesterday? Yesterday. So there's the horizontal. Oh, and the last question is they have you put it on your graphing calculator and graph it. I'm just going to move on. Just type it in, y1 equals, put that thing in, hit the graph button, and you can get the graph. If you have any trouble, come grab me. Be glad to help you work with your calculator. I want to leave at least 15 minutes for those last 3 questions are tough. So I'll try to watch that clock. Okay, so this one, domain. Domain is just denominator. Not equal to 0 for domain, as you know. And that's easy. X squared minus 36 cannot be 0. That's x plus 6. X minus 6 cannot be 0. So x cannot be 6 or negative 6. Next question, vertical asymptote. It's going to be the same. 6 negative. The only time they're different is when something cancels. Am I being clear on that? We'll see one of those in just a minute. The only time there's a difference between domain and vertical asymptote, well, actually, domain can have a square root problem too. Aside from that, if it's just denominator issues, the only time they're different is if something cancels in the fraction. I didn't even bother to factor it. X cubed minus 125 is not going to factor and cancel anything with the bottom. So they're the same. So most of the time, 95% of the time, 98% of the time, domain and vertical asymptotes are the same. Only time they're different is when something cancels, which I'll show you in just a minute. Go on to horizontal. What's the story with horizontal? It's horizontal or oblique. What's the story with horizontal or oblique? Yeah, so So we have x cubed minus 125 over x squared minus 36. The numerator is 3. Denominator powers 2. Numerator is greater than the denominator by only 1. What does that mean when the top's bigger? They do the tug-of-war. The top wins. He's going to pull the graph up, up, up to infinity, but he barely wins. He only wins by 1. Right? What happens if you have x to the third over x squared? Well, x to the first. Meaning linear. Y equals mx plus b, oblique, slant, asymptote line. Not flat. Not flat. When they're equal powers, when they tie in the tug-of-war, then it's flat, right? If they're both third power, both second power, it'd be a flat horizontal asymptote. But this is oblique. It's going to head off diagonally because the top will win. He's going to take it up to infinity, but he'll take it up in a linear fashion because he's only 1 degree higher than the bottom. So this is going to be oblique, right? Remember that? So then how do you find the exact equation of the oblique asymptote? You got to divide bottom into the top. Remember that? So you got to take the bottom, x squared minus 36, and long divide it into the top. So we have had a couple of these now, so this might be on the next exam. Oh, I put it up. The proxem is up. I got that up. I think I promised it by the end of the week. It's up. I got it up last night. So if you go on the first page, under announcements, open it up. The second practice exam is now available. We're still 2 weeks out from the real deal, but I want you to have it in advance. Answers are there as well. You can be looking at that thing, working on those if you want to do that. All right, so remember how to do long division? Maybe not so much. Front to front. What do you put right here? Times the front that'll match the front. X, right? X. So you put an X right there. Boom, boom. So it'd be x cubed minus 36x. Good so far? Draw your line, change your, subtract them. So, boom, those are gone. What happens then? Well, you just bring down the minus 36x and the minus 125. They can't, they're unlike terms. They're not going to interact. Good so far? Now, what goes next? Nothing. It's impossible. We're done. Do you see that? What could you put right here? Times x squared, that'll match x to the first. You can't make the power lower. I mean, you put negative 1 power. We're not going to do that. We're done. This is all remainder. And we don't care about that. Answer is just x. It's y equals x. That is the oblique asymptote. Y equals x. Just x. Cyrus.
Oh, because on the top, that's all that's left to put up there, so you just put...
That's all that's left to put up there. Yeah, there's nothing else you can put up there. Because x squared, you can't multiply something by x squared and make it match x to the first power. If this was x squared, if this was minus 36x squared, then yeah, I'd put minus 36, and that would match, right? Everybody see the difference? Problem is this power down here is lower. Can't do that. That means it's just a remainder, and that's how you know when you're at the remainder step, is when what's left is lower power than what you have here. That's all remainder at that point. Does that make sense? When this is lower power, it's remainder. So it's just y equals x. And that'd be the oblique asymptote. The rest is hit the buttons in your graphing calculator. Okay, so y equals x minus 17 squared over x plus 16 cubed. Okay, so let's do the domain. And you know what that means? Denominator, not 0. So that's x plus 16 cubed. Cannot be 0. What can make that 0? X plus 16 to the third power. How's that ever be 0? What can you plug in for x that will ever make that 0? Negative 16. Right? X cannot be negative 16. Right? Negative 16 plus 16 be 0. 0 cubed is 0. The cube doesn't do anything, right? Just 0 cubed is 0. Right? We good there? And what's the vertical? Same thing. It's always the same unless something canceled. So vertical is, all right, x is negative. That's what makes the bottom 0. That's what you can't do, and that's where there'll be a vertical asymptote, right? How about the horizontal? Remember, you take the numerator power, denominator power. But think in behavior. What's the if I was to FOIL out, I'm not going to bother to do the whole FOIL thing, but if I was to FOIL out, what would be the front term? What would be the in behavior? Third power, right? Because this will become squared, and this is first power. The bottom, x cubed also. Right, you with me? In behavior is x cubed over x cubed. So x cubed over x cubed, they're equal. The tug of war, they equal. They tie. And so it's just a over b, coefficients is 1 over 1, 1. So y equals 1 is the horizontal. Is that too quick? Remember those instructions I gave last time? If they equal power, then you just cancel them out. It's just y equals 1. I wrote it a over b, where a and b are the numbers in front of those most powerful terms. Right? That's how I wrote it in your setup yesterday. It's just 1. Y equals 1. What does that mean? That means at up 1, there's a horizontal asymptote at up 1. The graph will eventually approach a height. It'll come down and level out, or maybe from below, I don't know. It'll level out eventually, in the end, at a height of 1 because of the tie in the power levels and the tug of war on the top and the bottom. Question?
The a over b, when n equals b, that's the coefficients in front of the x's and the numerator and the denominator?
It's the coefficients in front of the most powerful terms in the top and the bottom, exactly. Yeah, so it's just like what we did in behavior. Right? Remember we did in behavior? We would just take something and we'd say, if I was to FOIL that all out, what would be the most powerful term? If I was to FOIL that all out, what would be the most powerful term? Yeah, and then that's the A and the B we're talking about, those numbers in front. That's right. Good, okay. This one's going to have a canceling, is what's going to happen. And so that'll make the vertical and the, what's it called, domain different, because there will be a canceling. So this is where I want to remind you that domain is done before any canceling. So do domain right now. Do domain right now. Just take that denominator, 4x squared minus 31x plus 42, and say you can't be 0. I don't care what the top is doing. Do that before canceling. There's going to be something that cancels in a minute, but domain is done before canceling because he's special. If anything was ever in the bottom that would make that thing 0, it's not allowed. Even if it later cancels, it was really there for a while. So it's really a problem. So, how to do that? We factor. How you guys doing at factoring? You getting more and more comfortable? I remember my daughters saying they hated factoring for the longest time. You can get comfortable with it. Just got to do it enough. So, what times what's 4x squared? Well, I would try 2x and 2x at first. It's not going to work. But normally we'd go 2x, 2x, right? Turns out it's going to be 4x and 1x. How do I know? Well, I just did the problem this last hour. But also, you can find out pretty quick here because you got to get 42 at the back, right? What times what's 42? Well, you should calculate if you're rusty on some of these. 6 times 7, good way to start. But you see the problem right away? Remember, you can't have two numbers in the same parenthesis that have anything in common. 2 and 6, 2 goes into them. No way. Can't do it. Well, switch them then. Switch them. Not going to help at all, right? Because then this 2 and 6 have 2 in common. Can't be. Why can't you have anything in common? Because then you could take out the 2. It'd just be 2 times x plus 3. Well, so what? Why is that the end of the world? Well, there can't be something coming out in common, or we would have seen it up here on step 1. 2 does not go into 4, 31, and 42. 2 doesn't go into 31. So there can't be a 2 in common, so there can't be a 2 coming out in common later. Can't be. It's not true. You do the commonness on step 1 if there is any commonness. There usually is not. So there's never commonness left later. If there was any to begin with, you get it out on step 1. It's never there later. So that can't be the case. 2 and 6 cannot be in the same parenthesis. So well, if I can't do 6, what else makes 42? You know, if you divide by 6, you get 7, so it's 6 and 7. What else? Divide by 3, you get 14. That's an option, but that's not going to work either. 3 and 14. 14 can't be in either parenthesis because he'd have 2 in common. Do you see how there's just nothing's going to work with those double 2's? See, that's when I go, wait a minute. The problem must be back with the 2x, 2x. Nothing is going to work with the 2x, 2x. Then you go, okay, let me do 4x, 1x. Let me go back to the 6, 7. And that way I can put the 7 with the 4 and the 6 with the 1, and there's no commonness problem. Do you see that? See how that's a reasonable? I'm going to actually try that now. Now I'm going to put in plus signs, FOIL it out, and I bet I can tinker with the signs and make it work. That's the first legitimate thing to try. right there. Everybody, the rest, don't even waste your time. Everybody see that? So now 4 and 7 have nothing in common. 1 and 6 have nothing in common. I mean, other than 1. 1 goes into everything. So let's try it. Is it right? Let's FOIL. 4x squared plus 24x, boom, boom, plus 7x plus 42. Does it make what's in the middle there? 31?
So it should be negative.
Should be negative. It's supposed to be negative
Both
31.
negative signs.
So make them both negative, huh? Make them both negative. These will both be negative. That'll be negative 31x. What was this? This was, I'm lost now. Minus 7. There you go. So, yeah. And then this is still plus 42 because 2 negatives make positive 42. It's right. That's the right factoring. All right. So there's the right factoring. So then you just solve each one separately. You say 4x minus 7, you can't be 0. And x minus 6, you can't be 0. So 4x, you can't be 7, divide by 4. X, you can't be 6. So can't be 6, can't be 7/4. Those two values are not allowed. Either one will make the denominator 0. Now, though, we're going to go on to vertical, and there will be a difference. This is the first one. We're going to have it. We're not just going to say, same answer for the vertical, which we normally say, but you have to check, does the top factor? Yeah, it does this time, and it's going to cancel. Let me do it over here. So for the vertical asymptote, you factor top and cancel. So you first cancel, then you do the denominator stuff. So look at that top. 28x squared. Here, let me change the color here so I don't get it confused. So 28x squared minus 29x minus 35 equals, well, I'm not equal, just factor it for starters. How's that factor? Well, probably 7x, 4x to make 28, right? Good, so that you getting the hang of factoring a little bit better? Get this one out of the way. This one was x cannot be 6. So, and now 28, and what makes 35? What times what's 35? 5 and 7. Now, can I put it 7 and 5 like that? No. 2 7s in the same parenthesis? No way. So switch them. Put the 5 here, the 7 there. That's probably it. Put in both plus signs and give it a check. Multiply out 28x squared plus 49x. Boom, boom. Plus 20x. That's a 20. I'm scribbling now. Here, I'll just put it right below it. Plus 20x plus 35. Does that work? Well, it makes 69 in the middle. I want minus 20. Is there a way to fiddle with the signs, though, and get that to work?
Yes.
What do I do?
Minus.
Yeah, I want minus 49 plus 20, don't I? And that'll make minus 29x. And I need this 35 to be negative. Isn't that what it is? Yeah, negative 35. That'll make negative 29. See that? Negative 49 plus 20 is negative 29. So how do you make those two guys negative?
Negative.
Is it the 7? Yeah, it's the 7 we got to make negative. This back 7, huh? Because that would be negative 49, negative 35. Yeah, perfect. So there's the right factoring. 7x plus 5, 4x minus 7. Everybody see that? It's just guess around a factor until you get it. Now, all that to say, there's the numerator, and notice that's going to cancel with the 4x minus 7 in the denominator. So I'm going to write it as one big fraction now. So it is 7x plus 5, 4x minus 7. The denominator is 4x minus 7, x minus 6. Boom, they cancel. We didn't do that for domain, right? You do domain before canceling. But for everything else, you cancel, of course. So what do we have left in the bottom? Only x minus 6. So it's only x equals 6 then, is the vertical asymptote. You with me? So the vertical asymptote came out different than the domain this time. The domain was 6 and 7/4. The vertical's only the 6 because the other part canceled out. So I wanted to be real clear with you on that. Domain is done before canceling. Everything else is after canceling. The rest is the same. Type it in your calculator, graph it, blah, blah, blah. Can you tell me the horizontal? Can you just look at that thing and tell me the horizontal? Can you see the original function? Remember, it's all you need is most powerful term, most powerful term. So the horizontal, 28x squared over 4x squared. That's all we need for horizontal, right? Cancel those. Y equals 7. The x is all canceled out. It's just 7 on that. Yeah?
Oh, wait, I was about to say, can't you, don't you do it, find the horizontal while it's factored?
No. No, because remember what we need for horizontal, what do we need? End behavior. And end is multiplied out. Most powerful term, most powerful term. Good question. Everybody see that? So for horizontal, we need a different thing. We need end behavior, most powerful, most powerful. So most powerful, reduce them, 7. It's got a horizontal asymptote up at 7, doesn't it? Because they tie. They tie in their tug of war. And so it's just 28 over 4. It's just A over B, which reduces to be 7. Good? All these good? Look, mad at me if I don't spend time on those word problems. Let's do this. X plus 1 over x. Yeah, the deal is for vertical and horizontal asymptote stuff, you must make into one fraction. Yeah. I know sometimes, like yesterday we did some stuff where we wanted it to be two separate. Sometimes we do. But for vertical and horizontal, you've got to put those guys together with common denominator and make them into one fraction. Why? How do you know? Because all the rules I've given you, like look back. Say that was one fraction. Say that was one fraction. It wasn't like a fraction and something added off to the side. That one fraction, and on you go. All the rules I've given you for finding vertical and horizontal asymptotes, I've given to you in terms of the numerator this, the denominator that, right? So you got to make it one fraction to be able to follow that set of rules I gave you. You could make up other rules for separate things and da-da-da, but that isn't where we've gone. I've given you rules for how to do horizontal and vertical asymptotes for one fraction. So we have to put these guys together first before we can answer those kind of questions. So put this over 1. Remember when you got a whole number or a whole letter interacting with a fraction, put it over 1, make it look like a fraction. How do you add two fractions? Common denominator. Multiply top and bottom by x. So you get x squared over x plus 1 over x. Good so far. Now the denominators match. Boom, it's one fraction. We got it. Now we can go on and do the normal stuff we always do for vertical, horizontal, blah. I'm just going to go dot, dot, dot. Do all the rest. Is everybody seeing that? So that's the kind of thing you're going to want. That's the kind of thing that really tricks people on the exams. Because there's all these different looks, huh? Right? You got to be ready. It's like many things in life, you got to be prepared for the different looks. Right? Football season has started. I'm sure the defense is saying, when we see the quarterback do this kind of look or that kind of, they have all their plays memorized, right? Same kind of thing, right? Sports, whatever, foreign language. When you see this kind of thing, that you got to have a game plan. So when you see two separate things and you're doing vertical and horizontal asymptote, you got to make them one fraction, and the rest will be the same on that. What would be the what's the domain on this one? X can't be 0. And what's the vertical? Same thing. X is 0. Right? They're always the same if nothing cancels. And what's the horizontal? Asymptote. It's going to be oblique. This is 1 power higher than that. It's going to be oblique, long division. I don't got time for that. Da-da-da. Right? There's another one. There's been 3 obliques, huh? Right? When the numerator is 1 degree higher than the denominator, that's oblique. Real quick. Time's up, Heron. That's it. All right. So,
So they give you the graph.
yeah. So now, this will be on part 1 of exam 2. No graphing calculator. You can do it. It's not that hard. Let me lead you through it real quick. Right? So you'll see, like I said, the ProXM's out there. Take a look at it. It's out there. ProXM 2, part 1 and part 2. So it'd be the same way. Part 1, no graphing calculator. You have to be able to look at that without a graphing calculator and figure out which one it is. It's really not that bad. Let me show you. Look at those two verticals first off. That's it, +3 and -3 verticals, right? Which means those are in the denominator. x plus 3, x minus 3, right? Because verticals are always in the denominator.
So it can't be A or C.
So, yeah, exactly. A and C are out. Because that's x squared minus 9 in the bottom, isn't it? You with me? Not x squared plus 9. Right away, A and C are out. Because they have x squared plus 9 in the bottom. No way. It's got to be x squared minus 9. Right? Because we see the verticals are 3 and negative 3. Multiply that out, x squared minus 9. Good so far? We're already down. You can flip a coin at this point. We're already down to 2 options. 50-50 chance. Now, the only difference between B and D, one has a negative, one doesn't. Guess what I mean? What do I always do when I get down to 2 options with this multiple choice thing? Make a table, meaning just a point. Just all you need is 1 point. You got it. You can do this. So let's just find 1 point. And now, what point? How do you know point? Something easy. Just something easy. Just look at the graph. What's a really easy point? I'm thinking like this right here. That looks like what? Over 2, up to, about. I mean, I don't mean it's exact. But, I mean, these are negative, but they're going to be opposite. It's going to be clear. Right? That looks like over 2, up something. About 2. Right? So, does that really work for this? Or does that really work for that? Which one takes 2, 2, or about 2, 2? And which one is going to do the opposite? Well, let's see. Let's just plug it in. Let me try part B first off. So part B, which says y equals negative. He's got the negative. The other one doesn't. Now, careful. You might think, oh, that negative means it's going to go down. No. Actually, B is the right answer. But don't be guessing like that. Plug in the 2. You'll see. So let's plug in the 2. Now, x is 2. I'm not going to, and I'll see what y, if y comes out to be about 2. Plug in the 2. See, the bottom is going to be negative. The other negative is going to be positive. See that? Negative 12 over 4 minus 9. Negative 12 over negative 12. It's positive 2 point, I think it's 2.4. Yeah, that's about right. The other one would not have this negative here, you see. And therefore would come out negative 2.4.
Going down.
That'd be wrong. That's D. That's D. D's not right. So this negative is here. We need him. Makes it positive in the end. B is the right answer. You can do that without a graphing calculator, right? You can do that without any calculator at all. Good? So we do that. We got it down to B and D. Found it was B. All right, we better see. There's 3 challenging word problems at the end. These are super valuable. You know, there's no secrets with me. What does that mean? There's for sure one of these on the next test. For sure. There's these 3. There is for sure one of these 3 on this super important, super valuable, super practical. What you're going to do in calculus, absolutely. So definitely master these 17, 18, 19. 17, 18, 19 on exam 2. One of them. I mean all 3 of them. But one of them for sure. Basically, one of them is on the practice exam, and one of the other ones is on the real exam. So you'll have one of these on the exam. Okay, how do we do it? Well, I won't bore you with reading the story to you there. It's basically saying you got a river, and you're going to put 3 sides, pieces of fence, next to the river to make a holder for some animals. And you want 2,000 square feet area inside to hold the animals. There's different ways to build it, though. Like, there's different ways to get 2,000 square feet. For example, you could have 2,000 would be what? You could go 200 by 10, so it wouldn't look like this, right? You know what I mean? It would be like, yes, it'd be like this. If these 2 sides were 200 and this was 10, right? That is 2,000. Remember, area inside a rectangle is one side times the other, right? So area in here would be 2,000 because it's 200 times 10, right? So that would hold 2,000 square feet of area for the animals, but that would be a couple long pieces of fence. You could make it more. You could make it more like this, you know, and maybe this would be, I don't know, 100, and this would be 20. Yeah, 20 times 100, that would also hold 2,000, wouldn't it? Or you could make it more squarish, like maybe 40 and 50. That's 2,000 also, isn't it? 40 by 50. You know, 40, the 40 on the walls coming out, and 50. There's different ways to make 2,000. Which one's going to be the cheapest? Least cost for the fencing, in other words.
Closely even, close numbers?
Well, if all the fence sides were equal costs, yes, but they're also giving us different prices on the different parts of the fence. So that's going to affect the game. All right, so with that, overview in mind, let's get into the details.
Make sure the water doesn't flood them.
We don't have flooding issues, as we've seen on the news. That's a problem. All right, so here's the river. I'm just going to make it look like whatever. And this is going to be X, X, and Y. Because I don't know what they are. I know the top and the bottom are the same, so I'm calling them by the same letter, whatever they are. And this is something different. Different letter. Whatever. You can call it A, and B, or whatever. Doesn't matter. Just putting down letters. But the top and bottom are the same. This one's different. Okay. What's the cost? Well, they told me the 4 corner posts are $30 each. $30 each. And they told me the fencing that is parallel to the river. So that's this piece. He's parallel to the river, right? It's the most expensive. It's $10 per foot. And the other stuff that is $3 per foot, $3 per foot for the other two kinds of fencing. For these two, they're $3 per foot. Good so far? So then they're asking me for a cost equation. What would be the cost of all that fencing? Well, first off, let's do the 4 corner posts. 4 times 30, $120. Plus, now we got the blue fencing on the top. That's going to be 3x. The bottom 3x. The right 10y. We good? Because the fencing on the top is $3 per foot, x feet. Bottom is $3 per foot, x feet. The right side is $10 per foot, y feet. So let's combine some like terms and stuff. What's that? 6x plus 10y. Good to there? Now, here's the real trick. Here's the big idea you need to get for these 3 problems. 17, 18, 19. All use 2 formulas. The second plugs into the first. We did that one other time. It's substitution. Why? Because I don't want that y. See what they want from me? They want c of x. They only want x. They want the cost function in terms of one letter only, because we're going to put it into our graphing calculator as y1, graph it and find the minimum in a minute. So we don't want y. We want only x. That's what they're saying, c of x. So how do you get that to only be x? You use the second formula. What other formula? What else did they say? The 2,000. Remember the area is 2,000? We use that fact. Area. And what's area of a rectangle? Length times width, right? 2,000. And what is length and width? X and y. X times y. So that's the second form. That's what's tricky on these. They're all like this. They all have 2 formulas. And you use the second one to substitute back in the main one. See what I could do now? Just solve for y. Boom. 2,000 over x, and plug it in right there. Y is 2,000 over x. You tracking with me? So then we've got our cost formula. The cost is 120 plus 6x plus 10 times 2,000 over x. Y is 2,000 over x.
Is that it?
Well, you should probably multiply that 10 to the top, make it 20,000 over x. And that'll be it. That's the cost. That's what they want in part A. I don't got time. I'm going to set up, in our last 3 minutes, I want to set up the other ones with you. The rest is pretty they say, okay, now type this into Y1, graph it in your calculator, find the minimum. What's the best way to build the pin for the animals, and answer all their questions. But that's all the hard work right there, is getting that cost function. The rest is graphing calculator, find the minimum. But that's a skill too, right? Getting the right graph on the screen. I wish I had time to do all that with you, but I don't. So I'm going to move on.
What's messing you up?
The shifting, because you look at it and it jumps on you. Yeah, right. Okay, so I don't know if you can see this. This is x, x, and y, the 3 sides of the cube. And they're basically asking me for the surface area. How many sides on a cube? 8. Mr. Rubik's Cube man here, right? 6 sides, right?
Or 6, yeah.
Yeah. 6 sides to the cube. So we're going to have to add up 6 things. Let's do the bottom, top, front, back, left, and right. 6 sides to the cube. We need to find the area. There's 6 rectangles, aren't they? Find the area for each rectangle, add them all up. 6 rectangles, all added up. So let's start with the bottom. What's the bottom here? X times x. X squared. Right? Rectangle is just one side times the other. The bottom is x by x. What's the top? Same thing. Top and bottom are the same. Right and left are the same. Front and back are the same. They're going to be in pairs of 2. Right? All right? Good for the front, top, and bottom? Now what's the front? The front,
X times Y.
X of Y.
yeah, is right here. It's x by y. Its dimensions are x and y. See that? And the back's exactly the same. Back here. Front and back are the same. Good. And now, what about the right?
X times Y.
It's going to be the same thing. And here's the right side. X and y again. Well, I did left. Left and right are both x and y. So we actually end up with 4 xy's, don't we? So the surface area formula is 2x squared plus 4xy. Now what can we do with that? We can't have the y. No y. So what do we do about that? Second formula. Remember, there's always a second formula. What's the other formula we haven't used? This volume fact. Volume, how do you find the volume, the space in the middle of a cube? Length times width times height. The volume is 10,000. And that is xxy. xxy, which is x squared y. How do you solve for y? Remember, we're trying to solve for y and plug in to the other one. Divide by x squared. Y is 10,000 over x squared. Plug that in. $10,000 over x squared. Do you see that? There's the surface area formula. Now you need to cancel here, right? This x will cancel one of these, and the 4 and the 10,000 will multiply. So you get 2x squared plus 40,000 over x. I don't know if you can see all that. Yeah. Right? Because 2x squared, and then the x cancels, because this is 4x over 1, isn't it? So the x's will cancel, and 4 times 10,000 is 40,000 over x. All right. I think is easier because they're handing you the formulas. You don't really got to come up with them on your own. See, so basically there's, oh, I can't see what the costs are there. Something's 3 cents.